Hi, my name is Arthur, and I'm a member of the Solutions Engineering team here at Commodore. Over the next several minutes, I'll be walking you through why Commodore is quickly becoming the go-to solution for managing enterprise Kubernetes at scale. If we're being honest, Kubernetes is hard, especially for developers that are just getting started on their case journey. Commodore helps accelerate and empower developers by providing them with access to only the things that they need so that they can quickly and easily troubleshoot, operate, and own their applications. Here we can see what we call the Workspace overview. Think of the Workspace overview as a dashboard that's designed to provide developers and application owners with a very focused view of only the things that they care about. I can see things like how my availability issues have been trending over time, what my cost optimization score looks like, and which microservices need to be right sized, as well as if I'm violating any policy checks or guardrails that have been put in place. We've got things like best practices around resource limits and requests, missing liveness probes, security best practices. There's actually a ton of these policies and guardrails that we'll be taking a deeper look at from the perspective of a cluster operator a little later in the demo. But for now, let's take a look at this missing resource limits or requests. We don't assume that you know what that means, so we take every opportunity at Commodore to educate the user and understand why this is important. If we want to take a look at the actual payments processor that's violating this particular check and look at the issue, we can see that our memory limits and CPU limits are missing, why this is important. And even better than that, I can show you what some patch deployment YAML would look like in order to fix this issue. Now, let's assume for a moment that I'm the engineer that's responsible for the events puller service. Let's click into the events puller service and try to understand quickly what's going on and why it's unhealthy. The first place we come is what we call the events timeline. Think of the events timeline as the first pane of glass where both experts and non-experts alike can come to quickly see everything that's going on, not just with inside of Kubernetes, but the extended enterprise Kubernetes estate. By using a myriad of integration points with extended ecosystem partners, things like APMs and alerting tools, we can show you a very enriched view of everything that's happening leading up to the outage. This is how Commodore's customers can significantly reduce their MTTR, in some cases by as much as 64%. Now, let's shift gears and take a look at our automated troubleshooting wizard. As we dive into the wizard and actually investigate the problem, we're told immediately we've got a few insights. There was a deploy that happened 20 seconds prior to the issue being identified. We've got some suspicious log lines we want to take a look at, and we can see what our blast radius is. Who am I impacting or who else is down as a result of my application problem? Let's launch the wizard. And first, let's take a look at why we're here. We've got this non-zero exit code 137. We don't assume that you necessarily know what an exit code 137 is. So we take, again, a little bit of time to explain that this is an umkill error and even explain some of the things that can happen to cause an umkill error. I'd like to point out that these steps to investigate the problem are not a simple static decision tree. This is a dynamic list of things that the platform believes we can step through in order to better understand what the problem is and, more importantly, remediate the problem. Let's start the investigation. The first thing we take a look at is our dependency graph. This is a visualization of all the up and downstream dependencies that my service has. As a developer, I can come here and see what my blast radius is, but just as importantly, if I see something over here on the right-hand side, a common example I give is something like STOD sidecar, for example, that's unhealthy. I know that I could stop, grab this link, and open a ticket and escalate. Because if there's a problem with Istio with inside of my environment, as a developer, that's not something I'm going to be able to quickly influence. I need to escalate that to the platform owners so that they can help me resolve the problem. In this particular use case, I don't actually see anything that leads me to believe that there's an underlying Kubernetes platform issue. So we're going to skip this step for now and take a look at the container logs. Common feedback we get from our customers is that just getting the correct logs in front of the person troubleshooting the problem can actually be a significant barrier for entry when we're talking about onboarding new users to Kubernetes. So we automatically associate the logs for the failed container when we're troubleshooting these issues. In addition, we have what we call our AI log analyzer, which takes the log entries and sends them off with curated prompts to a large language model to get us jump started in essentially understanding what the problem is and how to solve it. In this particular case, the AI log analyzer has come back and said that we have a variable called API rate limit, which is actually set to a value that's larger than the acceptable maximum size. Based on this, the platform believes that the problem is actually tied to a specific configuration change. Let's take a look at the correlated deploy and start to better understand what that config change was and how maybe that influenced the current state that I'm in. The first thing I can see is a diff between everything that changed from the last deployment to this one. I can also see that there was a PR in GitHub, in this case by my colleague Guy Mahoney, leading up to this issue. And then finally, we can see what the platform believes the possible root cause is. In this case, this API rate limit that's a part of the event spooler config map changed from a value from 800 to 2500. From here, I can surmise that I ran my container out of memory as I approached that hard 2000 limit. So I can do a couple of different things. I can increase the container memory limit and reduce this API rate limit down to 2000. I could change it back to 800 and scale the deployment out, try to address the issue that way. Or I can even just review and roll back to what the previous known good condition is, and then go to my internal change control board and essentially approach the issue that way. But none of these things involved me opening a Jira ticket or angrily sending a Slack message to a DevOps engineer. And this is where Commodore drives what we call organizational efficiency, essentially empowering developers by giving them the tools that they need to understand when an issue is actually application related versus when that issue is platform related and needs to be escalated to the platform engineers. Now let's shift gears and talk about how Commodore helps customers gain cross-cluster visibility and improve their Kubernetes platform reliability over time. We'll start with what we call our clusters view. You can think of this dashboard as mission control for cluster operators. From here, we can see a list of all clusters across the entire organization, or break the view down by regions, teams, applications, whatever metrics makes the most amount of sense for your organization. If we click into the AWS cluster, we can quickly see high-level telemetry, like how many nodes we have, if any of the nodes are unhealthy, total number of services, pods. We can even see cluster resource consumption. If we roll down a little bit further and expand the reliability card, we can see that there are multiple high-risk violations that need to be addressed in order to avoid potential service interruptions. I can see that the cluster is rapidly approaching its end of life, and that some of my CRDs are going to need to be updated before I can safely upgrade to the next version of Kubernetes. I can also see that there's an ongoing node pressure issue, something that can be challenging to diagnose, and the root cause can often be elusive. Clicking into the issue, we can see that Commodore has identified a noisy neighbor. Upon further investigation, we can see that this service has no memory limit set and that it's suffering from a memory leak, causing our worker node to reboot. I can also quickly assess the blast radius, which provides me valuable insight into the root cause of multiple cluster performance anomalies resulting from this single noisy neighbor. In just a few clicks, I've quickly identified the node pressure issue and can take steps to correct it. Additionally, we can see those guardrail policies that we talked about before. I can see that several of the policies that I have enabled for this cluster are being violated. Things like that root privilege escalation, or even a single point of failure alert that's going on. Commodore provides customers with a wide range of customizable policies that provide the necessary guardrails needed to speed up migrations and developer onboarding. Finally, we can see how resource efficiency, allocation, and essentially cost are impacting my ability to schedule workloads within the cluster. Speaking of cost, let's jump over into our cost optimization dashboard. Commodore understands the natural intersection between cost and workload performance. Our optimization engine is continuously monitoring workloads in order to ensure that performance isn't sacrificed when right-sizing. Commodore is able to provide detailed analytics around resource consumption and allows our customers to safely right size workloads, resulting in fewer wasted cluster resources and ultimately lower cost. Thanks for taking the time to see why Commodore is quickly becoming the go to solution for managing enterprise Kubernetes at scale.